Welcome to this video. That's a follow-up to the Build with AI event with GDG Abuja. So this is the recap of the multi-agent system that was built during Build with AI with GDG Abuja. So what we did was we built a multi-agent system using Lanchain and Gemini, right? So what's an agent? An agent is basically a piece of software that can act autonomously, right, on its own to solve or perform specific tasks. So agents are typically not general purpose; they are mainly specific. So in our own case, we have a situation where a user enters a query to the system. Then we have a conversation agent, right? Conversation agent. So typically your agent have tools, right? Just like if you have a mechanic is a specialist as certain things, so he has his own tools for carrying out his task, right? So an agent can have tools, but in this case we are leaving this with no tools just for demonstration. Then we have a nutrition agent that finds okay, what item is being searched for. Then that has a nutrition tool. So let me see if I have a more updated version of this image. Okay, let's just go on. So we have an inventory agent. An inventory agent has an inventory tool. So the inventory tool searches a CSV file to see if we have an item in stock. Then if the product is available, we return the nutrition content of that particular item. So at the end of the slide, you're going to get the starter code. We're also going to be sharing the slide. So you're going to get the starter code. So when you have the starter code, you have some of the basic skeletons to get started with the project. So now Lanchain has a collection of tools for different purposes. There's tools for database management, tools for internet search, which we're going to be using one to search for nutritional value of an item. Then it has a host of other tools for automating different things like productivity tools for Office 365, managing your calendar, managing Gmail, and so on, right? So we're going to be using one of the tools from Lanchain to in our nutrition agent. While on the other hand, we're going to be creating a custom tool for our inventory agent to search our inventory. So when you download this piece of code, this is what you have. You have the API key where you enter your Gemini API key. So you can get your API keys from here, right? From this link, aistudio.google.com. Then we're going to be using Tabili to search the internet, so you can get your Tabili API key from here. So once you have them, the API keys, you can replace the values here. We've written the front end for you, so you don't need to worry about this, right? We've written the front end. Then yeah, so that's basically it. Then we have our source of data, which is what our inventory is, or our inventory agent is going to be searching through to find the item and the quantity to check the availability, right? So yes, so before you get started, you need to run this command in your command line on your terminal, pip install. So we need Lanchain, Google Gen AI, Lanchain community, Tabili Python, and Streamlit, right? So those are the things that you need. So once we are done installing all these packages, right, then we can move to writing our code. So we need operating system to set our environment variables. So in your own case, you're going to be using from API import API key Tabili, but I have my own keys here. So just because I don't want to share that in version control, so I'll just set it to this. So we're going to be using Lanchain. Our chat agent is going to be chat Google generative AI, and we're going to pass in the version of Gemini we need. So let's start. Let's get to coding. So the first thing we need to do is to set our environment variable. So os.environment set Google API key, and this is going to be the API key. So it's going to be this API key. So also going to set the Tavili API key. So API key, and this is just Tavili, right? So once we've done this, it means we've set our environment is ready for us to build, to communicate with Gemini and to build our model. So we're going to build an LLM. So, and this LLM is going to be of type chat Google generative AI. So we need to pass the model. So the model now is basically the version of Gemini we're going to be using. So we're going to be using Gemini 2.0 flash 001. If this is dash here, we'll set the temperature. So set the temperature to 0.7. We don't want it to be too creative, so the temperature just basically sets the how creative the model is with its results, right? So if you want it to be very, very artistic, you can set it to higher numbers like 0.9 and so on, right? And we set our max generated token, max tokens. So we'll just set it to 500. We don't want more than 500 generated words. So we can leave our model as it is. So to search our inventory, I've gone ahead to write the function for this. So we have the check inventory function. So we pass in the item and the quantity of the item we're looking for, and our source of data is the shop.csv, which is this file, right? So we open the file and we read in the contents of the file. So once we've loaded the contents of the file, we can now iterate through each row, right, in that in the data that we've read. We're converting everything to lowercase since all the items in our database are all, well, we're just converting everything to lowercase on both sides. So we first get the quantity that is available. So in this case, we get, for Apple, we get 20, right? So we get 20 and store it in available. So we say if available is greater than or equal to quantity, right? That means whatever number you are requesting for, we have either that same amount or we have more than that. That means the item itself is available. So I can now say item is available, requested maybe 10, in stock 20, right? Else we just say only 10 units of apples are available and you requested 20. So that's basically what this function does. So we wrap the function within a try catch block because we're dealing with files, just in case the file itself does not exist. So we throw an exception saying error checking inventory. Then the next function we have here is inventory check natural language. So we just use this just in case if you are building a system where someone has to enter I want 20 apples, right? You should be able to extract the quantity and the item using this regular expression to know the availability of that particular item within the string that is passed. Then once you have the quantity and the item, that is now used to check the inventory. So if there's no match, it will now say it could not pass item and quantity from input. So these are just basically the custom functions we are just going to use to check our data, our database. I just want to make sure that this starts at the beginning. Shouldn't be nested inside this. So let me remove. So yeah, I think that should have fixed the indentation problem. So now that we are done with that, we can now go ahead to create our inventory tool. So our inventory tool is just going to be inventory tool, and this is going to be of type 2. So I'm just going to name it inventory checker. So when creating agents, right, it's always good for everything to be descriptive, because the words you use goes a long way to determine the performance of and the efficiency of that particular agent and the application at large. So now our function, or the action of our tool, our inventory tool, is going to be this inventory check natural language, right? So I don't think we need this. Then description. So we now have to describe what this model, what this tool is going to do, right? So I'll just copy the one we used during the live session. So I'll just add that here. So use this tool to check inventory for a specific item and quantity. Input should be of the format X items are available, or X items is available. Example, 5 apples are available, so on. So this is a very, very descriptive message, right? So with this we've already created our inventory tool. So now we're going to create our search tool. So the search tool is what we're going to now use to search for the nutritional value of the items within or the items that the user is trying to search for. So we're going to say search tool. We're going to set it to Tabili search results, and we'll set the max results. This is how many websites do we want the Tabili search service to look for the meaning or the nutritional value of particular items, right? So with this now we've created our tool. So this is already done using through Lanchain. So that's why we don't have to write as much code as the previous one. But this is just to show you that you can create your own custom tools, as well as leverage the tools that have already been written. So we now have nutrition tool. Nutrition tool, just like the other one, is going to be of type 2, and the name is going to be, let's say, nutrition information or info, right? Then we're now going to use our tool, our search tool. I'm going to say search tool. So this is how we execute our tool using the run function. So say nutrition information of, so whatever is supplied to the nutrition agent. So we now get the nutrition information of that particular item. Then the description. So for this we can just say gives the nutrition facts of a given item. So we can have it this way, right? So we've now successfully created our tool. So we have our inventory tool here that uses our custom inventory function. Then we have our Lanchain based tool that uses our nutrition tool that uses our Lanchain tool, right? So we didn't write any code, we just passed a parameter here, and that was it. So with this, we've successfully created both tools. Now the next thing we have to do now is to create our agents and equip them with the necessary tools. So let's just come back to this image for a bit. So if you look at the tools, right, it's a list, it expects a list. So that's to tell you that an agent doesn't necessarily have to have only one tool. Your agent can have multiple tools, right? It can be a list of tools. So so I just wanted to make that just wanted to state that so that it's clear. So now we can move on to create our agent. So we're going to create a conversation agent. So we create our agent by initializing the agent. So if you come back to the top, you see where we imported this from Lanchain.agents. You can see the tool as well and agent type. So we can now set the tools of the agent. So we're going to have our list, and in this case we're not going to pass any tool to this particular agent. So the next thing is the agent. So this allows us to set the agent type, right? So we're going to set it to chat zero shot react description. So basically it has a chat component. The zero shot means it's able to adapt using context now to be able to give relevant responses. This react is just an acronym for reason and action, right? So that's what this agent does. There are different types of agents obviously that you can create. So if you want to create like an agent that learns from a particular source of information, like RAG based type of system, you can actually create those agents, and they are well documented online on the Lanchain's website. So the next thing we're going to do is to add memory. So the reason why we're using adding memory, in this case our application doesn't necessarily have like a recurring conversation feature, but it's always good for your models to have memory so that context itself is maintained. So we're going to set our memory key, and this is just going to be chat history, right? So the next thing we'll do is to set variables. Since we are developers, we want to see what's happening in the background, so we'll set this to true. So for simplicity, we're just going to leave most of our agents this way. So I'm going to take this and I'll change this to inventory agent, and we're now going to pass in the inventory tool. Then we now create our nutrition agent. And we pass in our nutrition tool. Right, so every other thing is just basically the same. So lastly, what we're going to do is to write a function that is going to now execute our agents. So we just call this run agents, and it's going to take an item of type string, quantity, and this is going to be of type int. Then can now say combo, for short for conversation. This is going to be our conversation agent. So for this we just say tell me what so we have that. So we're now going to form the query for our inventory. So I'm just going to call this stock query, and this is just going to be a string. Check if quantity so it can be check if 5 apples, right, are available in stock. So now we now get the stock using our inventory agent. So we're now going to run the stock query. So lastly, we need to get nutrition, and this is going to be nutrition agent, and the only nutrition agent run, the only argument it expects is just the item that is whose nutrition is going to return for us. So we are now going to return the convo, the stock, and the nutrition. So with this, we've successfully run our agents, right? So we've created our tools, we've equipped our, we created our LLM first, we've created our tools, our custom tool, and we've used a Lanchain tool to search the web. We've created our agents. Typically your agents should have tools, but for demonstration we're leaving this one without any tool. Then we've equipped our agents with their tools, and we've set their agent type, and we set variables to true so that we can see what's happening in the back end. And now we have run agents. So let's just move over to the front end so that we can just see how this works. So there's a text input where you enter what you're looking for. We set it, the default value is banana. Then the quantity is minimum value is 1, and the first value, initial value, will be 1. Then this is submit button. So if you submit, we now call that run agent function, which is the last one we wrote, right? We now call that function, which now returns the convo, the stock, and the nutrition, which is what we now display to the user. So we now we display the conversation, we display the stock, and then lastly we display the nutrition value. So once you're at this stage, you can now run this command, streamlit run front end. So hopefully everything works. So we missed one parameter for creating our agents. So we're going to set the LLM to LLM, which is the Gemini based model that we created. So LLM is going to be equal to LLM. So we do this for all the agents. So let me terminate this and run again. Let's see. So we have our front end, right? Set banana to this. So let's check the inventory. So the agent is working, or agents are working. So once it's done working and searching the internet, so you can see banana is a curved yellow fruit, blah blah blah. Banana is available, requested 1, in stock 15, nutritional facts, and we have our nutritional facts. So if we check, we have 15 items in our stock, right? So let's look at how this works. So when we started the conversation agent run, right? So it now started thinking, I need to define what a banana is. I can use a search engine to find the definition. So it's basically saying that, okay, if it has a search engine tool like the one we have for nutrition, it can find what a banana is. So it now told itself, okay, the action is to search, the action input is to define banana. Observation, search is not a valid tool. Try one off, and we have empty list, right? I apologize for this error. I do not have access to the search tool. I'll try to define from existing knowledge. So this is why I left that particular agent empty. So even though it doesn't have any search tool, right, it's able to use its own existing knowledge based on Gemini, right, to define what a banana is. So I'll define banana from my knowledge. Then we now have the final answer. A banana is a curved yellow fruit, blah blah blah, and so on. So once that agent is done with its action, the chain is finished. So the next agent now takes over. I need to check the inventory for bananas, right? Then has no observations. I need to check the inventory for bananas. So you now use the inventory checker. Remember, this is what we named our tool as, inventory checker, right? So you now use the inventory checker tool. So you now found out one banana is available, and the observation is banana is available. The requested amount is 1, and in stock is 15. Then it says I now know the final answer, and the final answer is 1 banana is in stock, and it knows the final and it returns the final answer. Then lastly, we have our nutrition agent. So our nutrition agent, I should use nutrition info tool to get nutrition facts of banana, right? So that's because we've equipped it with this tool. So with this tool, it's able to make a couple of searches. So it's a search USDA, right? And it has checked resources, nutrition, education material, seasonal produce guide, banana. So this is a very, very good source of information regarding nutrition. So remember, we set the value to 3. So we now checked for hers, blog banana nutrition. So maybe this is a diet-based website. Then there's healthlight.com, nutrition/food/banana. It's able to retrieve all this information. So it now says I have nutrition information for banana, and it now returns the final answer. Nutrition facts for a medium size banana, 100 grams are this, and this. So so this is just basically to demonstrate how to use agents at a low level in your programming. So you can see for stuff like this, the nutrition agent, we didn't have to write like a web crawler to go and search and now to strip down to find a concise way of returning this piece of information, right? So if you're writing this from scratch, maybe you have to use Python to, maybe if you're using Python, you now have to create a web scraper to find where each tag is, and to now refine that into something human readable, and that would take a lot of time compared to what we've just seen right now. And this is just the nutrition agent using one tool. You can use several tools for this particular agent. And well, to me, I feel this is one direction that programming is most likely going to go towards. We may not necessarily have to be generating code with AI, but maybe using AI to automate some of the process that would have traditionally written the code line by line for, and the agents will just simplify that whole process. So I hope this helps everybody, and it was nice seeing you guys at the event. Have a good one. Thanks.